Basic Programming.
Good day everyone! Once again, I am Teacher Jo and welcome to our computer class, which is Basic Computer Programming. Our topic for this session is Types of Computer Programming Languages. These are Machine Language, Assembly Language, High-Level Language. At the end of the topic, you will define Programming Language, categorize the different types of programming languages, and convert decimal to binary.
The objectives are: Number 1. Define programming language. Number 2. Categorize the different types of programming languages. Number 3. Convert decimal to binary. Topic 2. Types of computer programming languages. 2.1 Machine language. 2.2 Assembly language. 2.3 High-level language.
Language is the medium of communication, and to communicate with the computer, we need a common language. We call it computer language, a language that computer can understand. Let us learn about computer languages. If people want to talk to each other, they need a common language that both of them can understand. If one person speaks Hindi and the other person speaks English, both of them can't understand each other's language. How will they communicate? They need an interpreter who can interpret for both of them. Computer is a machine, so it cannot understand our language. It understands only two states of switches, that is, on and off. Switch on is represented by a code 1, while switch off is represented by code 0. These codes are called binary codes. Let us know more about computer languages. Computer language. As you know, computer is a machine that works on electricity. Depending upon the two states of electricity, presence or absence of electrical pulse, a computer can understand only binary language, that is the language of zeros and ones. We use ASCII, American Standard Code for Information Interchange, codes, made up of binary digits to represent alphabet and decimal numbers inside the computer. Binary language is also known as machine language. In the beginning, programs were written only in machine language, since it was the only language understood by the computer. Types of computer languages. There are three types of computer languages: machine language, assembly language, high-level language. Machine language. The lowest and the most basic form of computer language is the machine language. This language is coded in binary language, that is made up of zeros and ones. 0 represents off state, that is no electrical pulse, and 1 represents on state, that is presence of electrical pulse. Remember, a computer can understand this only at its machine level. Every instruction has to be written in zeros and ones only. The programs written in machine language are called object programs. Assembly language. Coding a program in binary form was very tedious. To overcome the difficulties of writing machine codes, assembly languages were developed in 1950s. These languages used symbolic codes called mnemonics to write any instruction. A mnemonic is a short name given to an instruction. For example, sum for addition and sub for subtraction. The program written in assembly language has to be translated into machine language, and then only it can be executed by the computer. Assembler is the software program that translates assembly language into machine language. The program written in mnemonic codes is called source program. High-level language. High-level languages use English language words to give instructions to the computer. A software program called interpreter is used to translate high-level language into machine language that a computer can understand. Nowadays, normally programs are written in high-level languages. Some examples of high-level languages are Logo, Basic, C, C++, Java, Visual Basic, etc. Advantages of high-level languages. They are easier to learn than assembly language. The programs written in high-level languages can be executed in any computer, unlike symbolic language programs. They are easier to maintain. They require less time to write. They provide better documentation. Caution: never work on computer continuously for several hours. Take a short interval of 5 to 10 minutes after working each 30 minutes. Some important terms. Program. It is a set of instructions given to a computer in a computer language. Software. It is a set of program which enables the computer to obtain the solution of a problem. Assembler. It is a program which is used to translate programs written in assembly language into machine code. Compiler. A compiler translates a program written in high-level language to executable machine language program, that is, the object program. The object program is generated and executed to get the desired result. Interpreter. Some high-level languages use interpreters to translate programs. Using interpreter, one instruction in the program is translated and executed. Then it takes the next instruction and translates it for execution. This way, each instruction is translated and executed one by one in turn.
Differences between different programming languages. And when you talk to people, you'll often hear that it doesn't really matter what language you start out with. You can transcend the limitations of any language and do good work regardless. And while that's mostly true, it does make a difference what language you start out with, because it's going to be your first language and it's going to color most of your conceptions forever forward. No matter what more you learn, your first language is special. Also, like with the spoken word, certain languages lend themselves more to expressing certain ideas. Whether you speak Mandarin Chinese or English or Cherokee, certain ideas are going to be easier, harder, impossible, or a pleasure to express. And the same exists with programming languages. So this is the verses line, and most computers in the early days used low-level languages because there was no other choice. And that is mostly assembly language, and that is versus high-level languages, which are more like English. They're easier to program. The words are more familiar. Python would be a great example of a high-level language, and C is an example of the lowest level of the high-level languages. The next thing is compiled versus interpreted. And this used to be really important. Interpreted languages were just so slow, whereas compiled languages ran really, really fast. But compiled languages have to be compiled, so it was slower to develop. You had anywhere from a couple minutes to a half-hour wait waiting for your code to compile based on how big your program was. Interpreted languages have a much faster workflow. You write, you run it, and you see how it runs, even though the running is slower. The next thing is whether your language is domain-specific, is the industry jargon, but they're just saying whether it's a specialized language. Especially in the early days where they were solving particular problems, a language might be written for scientific number crunching or for business, like Fortran and COBOL respectively, versus more general purpose languages. We're going to be focusing on general purpose languages. Those are the ones that you've mostly heard of. C, Java, Pascal, Python, Perl, PHP, Ruby. Those are all general purpose languages. Specialized languages you tend to not have heard of as much, but if you're in those fields, they're important. If you're in statistical analysis, there's the R language. If you're in mathematics, there's Mathematica. But as time goes by, general purpose languages even become more and more better at doing those specialized problems. So it becomes less of an issue over time. The next one is seldom discussed, but very, very interesting. It's whether it's a metaprogramming language versus a non-metaprogramming. Now, I thought of other ways to say that, like static maybe, but really non-meta is the best way to say it. A metaprogramming language basically means it can modify itself. There's very little difference between the way the programming language stores data and programming instructions. And once data can be treated as programming instructions, you manipulate data, you're manipulating the programming, and right while the programming's running, it can change underneath of itself. And you can use those tricks to solve classes of problems that can almost not be solved any other way. The granddaddy language in that category is Lisp, and Lisp has some very big advocates out there, mostly Paul Graham, and he'll make the argument that it's the best language because it can do things that other languages can't. The problem is that you'll be on your own. You essentially layer up layers of invented languages, because metaprogramming languages are great at writing languages. So to solve your particular problem better than anyone else can, you layer on solutions, and it's basically difficult for other people to step in and understand and take over your code. But it can be used for things like it was Lisp programming for the self-driving car that won the DARPA challenge to navigate across the desert. So when all else fails, sometimes you do resort to it, but we're going to be focusing on non-meta languages. The next thing, which is becoming more and more popular to talk about, is whether a language is sequential versus concurrent. Concurrency is very important for scaling. When you need thousands of things to happen at the same time, your program essentially breaks up into 1,000 bits, starts processing along these parallel lines, and gets to the finish line much more quickly than sequential programming would. With multi-core processors, concurrency is becoming more popular in the mainstream, but it's been around forever. Digital Equipment Corporation had a server called the VAX, which had clustering, and you just basically threw together a bunch of these VAXes, and your processing happened quicker, and you could swap out and upgrade, and your programs kept running. Similarly, Ericsson has a language called Erlang, where you could swap out components, and your code just keeps running. It's an amazing thing, and it's concurrency is becoming popular these days because of something called Node.js on the server, which allows a language called JavaScript to run on the server for non-blocking I/O. So basically, websites work quicker, and things that happen in the background don't stop your website, don't lock up your website. So concurrency is becoming more popular, but it's a little bit more challenging to program. We're going to be dealing with a sequential language. Python is sequential, and in fact its sequentiality is enforced with something called global lock. Hopefully they'll get over that limitation someday, but in the meantime our focus is going to be on a sequential language. The next one is probably one of the most hotly debated topics in programming, which is strongly typed variables versus loosely typed. Now what this means is that when you're writing your code and you're getting up to assigning a variable to a value. In the strongly typed languages, you have to say what type of variable it is, whether it's an integer or a string, what type of integer, how long the string. And in a loosely typed language, you don't even have to declare the variable. You can just start using it. And traditional thinking is that strongly typed is better because it keeps the bugs out. The compilers at compile time look specifically for errors, call them out, and you have to fix them. Now, the truth is that the compilers are getting smarter on the loosely typed side, just like they're getting smarter on the interpreted side, where execution speed is faster because they're building in compilers. At a similar location in the execution of the code, the interpreters are catching those mistakes. With loosely typed variables, ambiguity is your enemy. If something can be interpreted in more than one way, like if you say a plus 1, is that supposed to be the value of a plus 1, so it could equal 2? Or is it supposed to be appending a 1 onto an a, so the answer is a1? So the interpreters basically, for the most part, stop running when there's ambiguity these days and make you fix that mistake before you can continue. And the advantage of loosely typed variables is faster development. So a program might be 500 lines of code with loosely typed variables, but 1,000 lines of code with strongly typed variables, because you have to, declare all your variables, which can be a bottleneck. And then the final thing, most people would say, oh, what about object-oriented? Object-oriented versus everything else. Well, the problem is, what is that everything else? It's a whole bunch of stuff. There's procedural, imperative, functional. So it's not really object-oriented we're talking about. It's enforced programming style. Versus non-enforced programming style. And for someone who doesn't program yet, it's a little difficult to grasp, but object-oriented was a very popular trend in recent years, and it caused a revolution in programming, and it allowed a certain class of programs to be created that were very difficult before, because code is a lot easier to manage, and it's better for things like physics engines that are behind games, and it allows for emergent properties that you never explicitly programmed. But it's not the solution for every problem. You don't necessarily always want to be forced to think in the object-oriented style, because that's what it is. If you were to choose Ruby as your programming language, you would be forced to do everything, no matter how mundane, in an object-oriented style, as opposed to Python, where you can program object-oriented if you wanted to, but you can also program in the very popular procedural style or the increasingly popular functional style. Python is perhaps not your best choice for functional, but it's capable of doing it. And so when we go through our education curriculum, the choices we're going to be making are high level, interpreted, general purpose, non-meta, even though Python has a certain amount of meta programming capabilities in it, sequential, even though I hope that'll change someday and that the global lock gets removed from Python, loosely typed, and non-enforced programming style, Python. And that's the differences between a lot of different languages. You could map all different languages to these things. I'll do just a couple of those before we leave so that you get a little perspective. Low level would be assembly. Compiled would definitely be C. Specialized would be R. Metaprogramming would be Lisp. Sequential is Python, unfortunately for now. Strongly typed would be Java. Even more strongly than Java would be Scala. Object-oriented would be C++ and Ruby. And for style, again, Ruby. High level is almost everything you've heard of. Interpreted is all the P languages that you've heard of, Python, Perl, PHP, and the honorary Ruby. General purpose, again, is almost everything. Non-meta is almost everything. Concurrent, well, that's an interesting one. There's a few languages out there that are specifically for concurrency. Erlang is one of them. I believe Clojure is one of them. Loosely typed Python. And non-enforced Python.
What is programming languages? It is a formal language comprising a set of instructions that produce various kinds of outputs. Programming languages are used in computer programming to implement algorithms. Most programming languages consist of instructions for computers. Figure 1 shows examples of programming languages such as Java, C++, PHP, Perl, JavaScript, Python. Types of programming languages. Different levels of languages are used in the respective generation. Basically, each generation is an improvement of the latter generation. First type of programming language is machine language or first-generation programming language. This is considered to be the lowest level of programming language. The program is represented by ones and zeros to create instructions. An example is binary language. 0 represent off state. 1 represent on state. Figure 2 and 3 show binary codes.
Most fundamental sense, computers really only understand two things, on and off, which in computer language are represented by the numbers 1 and 0. This language, made up of just ones and zeros, is called binary. To better understand binary, let's take a quick look at the number system we humans use most of the time, the decimal system. The decimal system is a base 10 number system. We use the decimal system because humans have 10 fingers, so it makes sense to us to count in groups of 10. With the decimal system, we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once we get to 9, we've run out of numbers, so we have to add another digit. So we make 1, 0 to make 10. Then we get 11, 12, 13, 14, 15, etc. all the way to 99, and then we have to add another digit to make 100. Binary works in a similar way, except since we only have two numbers, 0 and 1, we have to use a whole lot more of them. Here's how it works. We start with 0, then 1. Now we've run out of options, so we have to use another digit. We get 1, 0, 1, 1. Now we've run out of possibilities again, so we have to use another digit. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now we've run out of options again, so we have to add another digit. We get 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. You get the idea. And if you don't, it probably doesn't matter. So why are we talking about this at all? Are you ever going to have to convert from binary to decimal or vice versa? Probably not. We're talking about this now so that when we turn to file sizes, everything makes a little bit more sense. Let's take a look at that now.
In your notebook, try to convert the following decimals to binary. A. 50. B. 100. Second type of programming language. 2. Assembly language. Or second generation programming language. This is also considered as low-level language. However, programmers would find this language easier to use than machine language. Instead of using ones and zeros, assembly languages uses mnemonic codes. Mnemonic codes are abbreviations that are easy to remember. Each type of computer has its own assembly language. Figure 4 and 5 are examples of assembly language. Figure 5 shows how to write simple program in assembly language.
The mnemonic code. 0, z or s, because 0 starts with z and s sounds similar. 1, t or d, because t has one downward line and d sounds similar. 2, n, because n has two downward lines. 3, m, because m has three downward lines. 4, r, because 4 ends in r. 5, L, because L is a Roman numeral for 50. 6, G or J, because G looks like an upside down 6 and J sounds similar. 7, K, because K looks like two sideways 7s and hard C has the same sound. 8, F or V, because F looks like an 8 when written in cursive and V sounds similar. 9, P or B, because P looks like the mirror image of 9 and B sounds similar.
Third types of programming languages. 3. High-level language. Or third-generation programming language. This language transformed programming in the early 1960s, makes programming easier since the language is now written English-like manner. If assembler low-level programming language that allows a programmer complete control of the machine code to be generated. Translator is used to convert the program to a machine language. Examples of high-level languages. 1. Visual Basic is a third-generation event-driven programming language from Microsoft known for its component object model (COM) programming model, first released in 1991 and declared legacy during 2008. 2. Python is an interpreted, high-level, general-purpose programming language. Created by Guido van Rossum and first released in 1991, Python's design. Another examples of high-level languages. 3. Java is a general-purpose programming language that is class-based, object-oriented, and designed to have as few implementation dependencies as possible. 4. C# is a programming language developed by Microsoft that runs on the .NET framework. C# is used to develop web apps, desktop apps, mobile apps, games, and much more. 5. PHP is a popular general-purpose scripting language that is especially suited to web development. 6. Perl is a family of two high-level, general-purpose, interpreted, dynamic programming languages. 7. ECMAScript is a general-purpose programming language, standardized by ICMA International according to the document. ICMA does 262 It is a JavaScript standard meant to ensure the interoperability of web pages across different web browsers.
To summarize our lesson for this session, programming language is a formal language comprising a set of instructions that produce various kinds of outputs. There are three types of programming languages. 1. Machine language, or the first generation programming language. This is the lowest programming language and represented by ones and zeros. 0 is off state and 1 is on state. In decimal to binary conversion, we will use a power of 2, which start to 2 to the 0 power, which is 1, 2 to the first power, which is 2, until it reaches 6th power of 2, which is 64. But it depends on the given decimal. If it is greater than 100, proceed to the 7th power of 2. The easiest way to convert decimal to binary is to put ones and zeros to any of the following: 64, 32, 16, 8, 4, 2, 1. Just add those numbers with ones, which makes the equivalent sum of the given decimal. Put zeros to the unused numbers, then write it according to their position. Number 2. Assembly language, or the second generation programming language. That's the second types of programming languages. Instead of using ones and zeros, assembly languages uses mnemonic codes. The third type of programming languages is the high-level language, or third generation programming language. Makes programming easier because the language is now written in English-like manner. Examples of high-level languages are Visual Basic, Python, Java, C#, PHP, Perl, and ECMAScript.
Do the activity. Categorize the following programming languages into machine language, assembly language, or high-level language. Write your answer in a clean short bond paper with your name, grade level, section, and the date today. 1. Java. 2. Visual Basic. 3. Fortran. 4. Binary language. 5. PHP. 2. Convert decimal numbers to binary. A. 49. B. 15. Z. 59. 3. Define programming language.
I hope you guys learned a lot from our lesson for this session. See you on our next computer class.